Joanna Deasy, your line is open.
He answered my question.
Thank you. One moment, we have one more. Mr. Kinosavo, your line is open.
Okay. I'm just wondering, will you be able to use this software to calculate the capacity factor for the solar system?
Okay, thank you for that. The capacity factor is an output in the metrics table, so you can see capacity factor here. For this particular case, happens to be 27%, and it's also reported for the trough, so it's 41%. So the answer is yes. SAM reports capacity factor among its results.
Okay. And another quick question: why you running through the software? I was just trying to run through it myself on my computer. I struggle a little bit. I'm just wondering, does this software have China and weather in the database, or they don't have it?
I'm sorry, does the software have what?
China, Saskatchewan weather information in their database.
Okay, so a question about whether there are Canadian locations.
Yeah.
I will answer that question in a moment because I think there's a couple of those. Thank you for that.
Okay.
John Furman, you may ask your question.
Yes, earlier you mentioned that you can't change the default database values for, say, inverters or modules. I've been using SAM for a number of years, and it used to be able to edit the Excel file, and I know that's now built into a SAM library, but I still see on occasion like well-known commercial inverters that have, say, missing voltage values. And so in other words, if I have a standard commercial inverter that I need to change or update to a correct spec sheet value, is there any way to edit those without like duplicating it?
Okay. Thank you for that question, and that's a few questions in there. So the question is, the one question is, can you edit the database values? And the answer is no, but you can, and this is an advanced feature. I'll just point it out briefly. On the File menu, if you click Libraries, this is a list of all the built-in databases. And it is possible to create a copy of a database or a copy of an entry in a database and create a custom inverter, for example, that's based on an existing one. And then you could specify your own parameters for that inverter. So that doesn't modify the existing database, but you can. We have provided the flexibility to run the model with different parameters. And there's some explanation of how to do this in help. But if you're going to be working with libraries, I recommend contacting us through the SAM support email address, and we can help you make sure that you're doing it correctly. The more specific part of your question, which is that the inverter database, some of the parameters are missing. The maximum DC voltage and maximum DC current ratings, which are manufacturer supplied values, are not available for all of the inverters in the database. And that's just because of limitations in resources and the ability of the folks involved in maintaining the database to get all of that data. Those values, and we're kind of getting into the weeds here, but I do want to answer the question. So those particular values do not affect the simulation results in SAM. When you model a PV system using the Sandia inverters, SAM does a check before it starts simulations to see if the the inverter and array are properly matched to the degree that it can, given the information that it has. And so it uses that VDC max and IDC max value in that pre-simulation check. So for the inverters for which those values are not available, you have to do that check yourself. So you just need to make sure that you've chosen the number of inverters that's appropriate for your array. SAM isn't going to display a warning if they're mismatched. So the lack of those values doesn't have an effect on the simulation results, just on that pre-simulation check.
Okay, thank you.
Next question is from Dan Pellegrini. Your line is open.
Yeah, hi. I have a question about the shading. Are you going to be getting to that soon?
I see another question. Oh, I see. You posted it written too. I can spend a minute or two on shading.
Well, specifically, the question is, can we do an analysis of self-shading for a single-axis tracker to prevent rotoro shading? As you change the ground cover ratio, obviously that's going to come into play.
Right. So the answer is yes. If I go over to the PV example, on the shading page, there's two SAM models, two types of shading. One is what we call array shading. Mathematically, the two shading models do different things. The array shading model assumes that models the shade as something that prevents light from reaching the array. So it calculates a shading factor and applies it to the direct normal component of the incident radiation. So it reduces the amount of sunlight that reaches the array, or mathematically in the model it reduces the value of the direct normal component of incident radiation. So you can specify those factors, those shading factors, in a number of different ways. So you basically what you have to tell SAM is during what hour to apply the shading factor. So if there's an object, the assumption here is that there's an object near the array that during certain times of day uniformly shades the entire array. So that's the array shading, or these beam radiation shading factors. That's what those are about. So you can either give SAM a file of 8760 hourly beam shading factors that maybe you've calculated on your own, or you can specify the beam shading factors using this month by hour table. So basically a daily shading profile for each month of the year, or you can specify the factors by sun angle. And then there is you can also, if you're running PVSYST, SAM will import shading factor files from PVSYST, and it also import shading factor files from SunEye, the SunEye device and software. Self-shading, that's what the question was about, rotoro shading, which we call self-shading in SAM. SAM does model them, but not for one-axis tracking, as you asked. So it can model rotoro shading for fixed arrays, and the shading model is pretty limited. You have to manually make sure that you specify the parameters for the shading model so that they match your array layout. So it's a little tricky to use. The description and help is pretty detailed. It should help walk you through the process. This is the first iteration of a rotoro shading model in SAM. So as resources allow, we can hope to see an improved model, rotoro shading model. So we do have a first iteration.
Are there plans to add that for the single axis at some point?
You know, I'm not sure what the status is on funding for that part of model development. It's certainly in our wish list, but I don't think it's in the plan for this next release in the spring of this year.
All right, thank you.
The next question is from, oh, I'm sorry, his line just withdrew from questions. We'll take Antonio Rodriguez. Mr. Rodriguez, you may want to check your mute button.
Yes. I have a question about doing your own climate, importing your own climate information, specifically for the trough technology. I don't have all the, I saw the help on the SAM model, and it just basically you do a copy paste of the parameters you have. But if I don't have all of them, I just was wondering what are the parameters used by SAM to do the calculations for the trough model, and which will be the most relevant if I don't have all the parameters. What will be the main ones that I need to run the model?
Okay, I will. I'll as soon as we finish this Q&A session, I'll answer. I'll go to the climate page and talk a little bit about that. What I will say right now in response to your question is that SAM can read weather files in one of three formats: TMY2, TMY3, and EPW, which is a format used by the Energy Plus building simulation software. And as you mentioned, it requires several columns of data, so not just the solar radiation data. And it's pretty tricky to build your own weather files in SAM that will work. There's several things. One is just getting the data and getting it in the right format and making sure there's no gaps and so on. And the other thing is that for this kind of long-term financial modeling that SAM is designed for, you really want to be using typical year data that represents the weather over a long period of time. So if you're modeling, if you're doing financial calculations that are based on a 30-year period, and you're running, and that's based on an estimate of the energy output that's from weather data for 2008, your results will be a little distorted because 2008 may have been an especially sunny year or cloudy year, or it's not necessarily going to represent the typical weather over that 30-year period. So as you're trying to figure out what weather data to use for your analyses, that's an important consideration. If you're ignoring the financial calculations and you're just using SAM as as a simulation tool to try to calculate the energy output of the system, and you do just want to run it for a particular year, and you have data for that year, then it would make sense to use your own weather data. And I'll go through the mechanics of that in a moment.
Thank you. Yes, I actually am we're trying to make a typical year based on also measurements. So when I go to SAM, I have GHI, DNI, DHI, but there's some of them that we do not include in our files. Albedo, for example, and I don't know if I copy paste the values that I have and I left the ones that SAM provides, if that's going to make a big difference, or if SAM actually doesn't take those. For example, Albedo, I don't think it will take it for a trough technology, so I just want to make sure which ones actually go into the
Albedo is not a critical one, and I think there's some discussion on this topic on the discussion board.
Okay.
And also, I would feel free to email me at solar advisor support at nrel.gov, and I can help you with that. But I will try to cover the list of columns that are required.
All right. Thank you.
When I go over the climate page. Let me take a couple of these questions that are on online. There's a question relevant to comparing cases. So I've got two cases here. One is using PV watts, and one is using the component-based models. And if you're comparing across technologies or across, I mean, PV watts and the way SAM is set up, PV watts and the component models are kind of different technologies. The only way to do comparisons is by setting them up in separate cases. For some comparisons, like for different cost assumptions or different size systems and so on, you can do comparisons using parametrics, which I'll be demonstrating tomorrow. And that allows you to create a graph within SAM that shows, for example, output versus nameplate capacity or something like that. You can't. There's not really a way to create a graph within SAM that shows output versus technology. So a graph that would have along the x-axis would be trough and PV watts and component-based, and then the y-axis would be annual kilowatt hours. That's not possible. Here's a comment about my switching from one axis to or putting the tilt angle in the one axis, and somebody saying that that's typically not the way they're set up, and that's fine. SAM allows you to choose whatever tilt angle you like. So if 0 is appropriate for your analysis, then that's great. And again, this emphasizes the fact that it's your responsibility to make sure that the inputs make sense. But that's a helpful comment that a one-axis tracking system would typically have a 0 tilt angle. I'm going to try to wrap up the financial example here by answering a few more of these questions. But let me get the non-financing questions out of the way first. So is it possible to generate a summary report including all input parameters? So the question is, is it possible to generate a report of all the inputs and all the outputs? And the answer is sort of. The case summary spreadsheet, which you can get to on the results menu, has a tab for inputs. And so this is a list of all of the inputs, but as you can see, the values are not all populated. So it's sort of a partial summary of the inputs. But this does have a lot of outputs all in one place. If you're handy with programming, if you can do VBA programming or program in other computer languages, you can use the SAM scripting language, SAMUL, it's on the developer menu, to write a little script that will write values of input variables to a text file. So that's one way to get a report of input variables. If you're running a lot of cases and you don't want to, you want to speed up the process. So unfortunately, not great reporting on inputs. The spreadsheet summary has some of that, and you can use Samuel to create your own if you can do a little programming. Okay, here's a question saying about the example that I gave. We specified a target IRR, a target internal rate of return for the utility case, and calculated a first-year PPA price. So the question is, what if I have a PPA price and I want to use that as an input? And the answer is, let's duplicate this case. And, oops, sorry. There's a financing option called, confusingly enough, first-year bid price. So if you, under the utility market option, if you choose first-year bid price instead of an independent power producer, that option allows you to specify the power purchase price as an input, and we call it a bid price. So if we go to the financing page on this utility bid price structure, those old constraints that we saw in the IPP option are gone, and now we have a bid price. That's your PPA price and an optional escalation rate. Now, a trick here, if you're going to use this financing option, is that this bid price is coupled to a set of payment allocation factors. And the payment allocation factors for PV systems are on an input page called Energy Payment Dispatch. And these are this is a financing structure or a cost structure, I guess, that is applied in California. So for those of you who are modeling systems in California, you may be familiar with this. I don't think it's available anywhere else in the country. And what a payment allocation factor is basically a way to adjust the PPA price with time. So you assign a factor to different hours of day and different times of year, and then SAM calculates a PPA price, assuming that the actual price that the project pays is going to vary over time based on the schedule that you specify here. So if you're not in California, you don't have to worry about this, and you should just be sure that the inputs here are as they are in the defaults, which is payment allocation factors of 1 everywhere, so there's no time variation on the power price. You use this option on the trough with the trough technology. You have to be a little careful because by default, SAM loads up a set of payment allocation factors. So let's see, we're going to change this to first year bid price for the trough case. And here the payment allocation factors are on the storage page rather than on a separate page. And here they are, payment allocation factor on the thermal storage page. And you can see that they're not ones. So if you just run this case this is only for CSP systems. If you run the bid price option, the utility bid price option for CSP systems, you need to either change all these allocation factors to 1 so that there's no time of use adjustment on the power purchase price, or you need to assign allocation factors that are appropriate for your project. So PV systems, you're fine by default. You don't have to worry about those allocation factors. Okay, the question, here's another financing question, is why does SAM consider tax savings as income in the cash flow? And that's just the way it's set up. For now, the financial model just assumes a single owner and developer, like there's just a single entity involved in the project. So all of the cash flows are assumed to be going and coming from the same entity. We're working on a new financial model as we speak that will be included in the next version of SAM that has some more flexibility for modeling of utility scale systems and introduces some new financing structures that allows you to separate cash flows for different parties in a project. But for now, they're all single party projects. At least that's the way the financing calculation is done in the spreadsheet. Okay, how do you account for a scheduled expense midway through the performance period? This is a good question. So if you might have a component replacement in the middle, in say year 10 of the 30-year period. There's a couple of ways to account for that, depending on how you want it to affect your cash flow. One is that you could just annualize that expense and calculate an annual cost and enter it as a fixed annual cost. And then in your cash flow, you'd basically be, each year the project would have to be putting aside a little bit of money to cover that cost that you know is going to occur in year 10 or whatever the year is. The other option is to actually assign the cost to that year. And so let's say that there's a $5,000 cost in year 10. You go to the cost page and scroll down to the operation and maintenance cost section of the page. And for fixed annual cost, click this gray and blue button. You'll see these scattered throughout the interface, and wherever you see that button, you have the option of specifying the variable either as a single value, as we have here, or as a schedule of values. When it's in schedule mode, the lower part of the button is blue, and the tiny little letters there spell out SCHED for schedule. But more noticeably, the value turns into a button. When you click Edit, that opens this table, and each row in the table represents a year. And so we can assign, say, a $5,000 cost to year 10. Maybe I'll make it a little bit bigger so it's really obvious in the cash flow table. Click Accept, and now when I run the case and look at the cash flow, you run it. Roll out to year 10. There's my $500,000 cost in year 10, and it's very small compared to the fixed O&M cost, so it's not visible in my graph. So if I changed it to something very larger than that, then I would see it in my cash flow table. So there's year 10. So this is all distorted. But so the answer is yes, you can specify a cost, a sign-up cost to a specific year to cover O&M costs. Okay. Let me answer a few PV-related questions, and then I'll go to weather, and then I'll move on to the CSP example that I wanted to show.
We do have 2 questions on the audio side when you have time.
Why don't we go ahead and take those?
Thank you. One moment. Rashmi Shah, your line is open. Mr. Shah, you may want to check your mute button. We're getting no response there. One moment, we'll go to...
Sorry, I was talking to another phone. I have a question. Can we model this system with a twin axis?
With 2-axis tracking?
Yeah, dual.
Yes. For PV systems, on the array page, you choose the tracking option.
Yeah.
And for trough systems, it assumes 2-axis tracking.
Yeah, because most of the Asian countries are going with that because they don't have a maintenance problem. Labor is not a problem for them, so they always go with the dual axis and get the things service and, oh, sure. You have a 2-axis. Okay.
Yep, and if you choose, obviously if you change the tracking option here, and this is true of the outputs throughout the interface, there's a cost associated with, you're going to affect the installation costs and also maintenance costs. So you want to make sure.
Yes, and it will increase the cost, the hardware cost.
That's right. So you need to account for those costs on the system cost page.
And will it pick up the axis by itself, or do I have to specify anything? Because the dual axis means it is going to track the movement of the sun in either direction.
Right. So if you choose a change the option here to dual axis tracking, this takes care of the performance part of the model. So the model will make sure that it's pointing the array at the sun. But this does not affect the cost part of the model. You would need to, on the cost page, make adjustments in your installation costs and in your operating costs as appropriate for your tracking system.
Sure.
Thank
you.
It
will give me the more production too. So that will offset my whatever the cost is.
Right.
Thank you.
Vladimir Namov, you may ask your question.
Hi. To go with the PV questions, you were talking about inverters a little while back when you stopped taking phone questions. Do you guys model parallel inverters where your modules are connected in parallel rather than within an array? Sorry, not array, within the string.
SAM isn't really an electrical model, so it's basically tracking kilowatt hours through the system. On the array page is where you specify the layout of the modules, and you have to make sure that the total inverter capacity matches your array capacity, so that the energy that the array generates, can be.
Well, it's just a different technology that's there to compensate for shading in different ways. Basically, it's more expensive, but you get less affected by shading. I was wondering if the model.
The SAM's model isn't really detailed enough to capture those benefits explicitly. So.
Okay. No, that's fine. Second part of my question would be some installers install more panels in terms of DC than the inverter capacity. So that shaves off the peak but gives you more performance throughout the less sun-intensive parts of the day. Can your model account for that in any way?
Yes. So you can size the PV array and inverter bank as you wish, and if you're trying to optimize cost or production.
Yeah.
So yes, the answer is yes.
So basically, when the array is outputting more than the inverter, it will just cut off the excess, and if it's okay. Okay, thank you.
You have time for one more, sir?
Sure, I'll take one more.
Mr. Masavo, your line is open.
I'm just wondering, in this software, are you able to specify the specific panel that you want to use in your design?
The specific component?
Yeah.
Yes. For PV system or trough or either?
Okay. Because I understand that each component has a different efficiency, and that goes along with to affect your capacity factor.
Okay.
Which determines your energy input.
Yes. So yes, the question is, can you specify components in SAM? And the answer is yes. And so let me do that. I'll spend a few minutes kind of walking through the PV model and show you the components there, and then I can also quickly show you the components on the trough model.
Okay.
Thank you for that question. So let's see. We've got the two options for on the PV side are component-based and PV watts model.
Yeah.
The PV watts model does not allow you to model the array and module and inverter as separate components. So it's a simplified model where you model the entire system using a single DC to AC D-rate factor.
Okay.
And for the PV watts model, there is a temperature correction algorithm. So the model applies this temperature correction factor based on the wind speed and ambient temperature data from the weather file. So it's the efficiency, the hourly efficiency isn't completely constant. There is a temperature adjustment. For the component-based models on the PV side, there's one. So photovoltaics is what we call the component-based model versus PV watts for the simpler model. Oh, I should mention one thing about PV watts is many of you are probably aware of the web version of PV watts, which is another NREL model, and that this model is equivalent to, it's based on the web version of PV watts. Although I think there have been some modifications between the two models, so you may not get exactly the same results between the two.
Okay.
The component-based models allow you to choose a module and an inverter. So you choose, you specify each component separately, and then on the array page, you specify factors that affect the system as a whole. So you've got a set of D-rate factors here. So basically what you have is you've got a radiation value coming from the weather file, and SAM calculates the incident solar radiation on the array, and it uses the module parameters to calculate the DC output of the array, and then it adjusts the DC output of the array using this total pre-inverter D-rate factor. So you've got DC output of the array. You can D-rate that using values that you specify to account for things like soiling and wiring losses that the module model doesn't account for. That results in a D-rated DC output, which is the input to the inverter model. And then the inverter model calculates an AC output, a gross AC output, and that value is adjusted by the post-inverter D-rate factor, which you can use to account for losses on the AC side of the system. And that gives you the total output of the system. So that's basically how the model works. And if you look at the results, if we look, say, at monthly outputs, we can see I guess we have to look in the hourly results to see, we can see the gross DC output. So that's coming out of the array. And then the derated DC output, that's accounting for the derate factor that you specify on the array page. And then the gross AC output comes out of the inverter, and then that's derated by the AC derate factor. So those variables are available for you to see. I think that answers a question that was on about derating factor.
Yep.
Okay.
Yep. Thank you.
That was the last question in the audio queue at this time, sir.
Great. Thank you.
You're welcome.